Moving on to the final problem for homework number 6, let's go to problem number 17. The statement for problem number 17 reads as following. If the Reynolds number for water flow through a pipe is 35,000 or 3,500, calculate the water velocity if the pipe diameter is 25 millimeters and 150 micrometers. Do you expect the flow in MEMS devices to be turbulent or laminar? Explain. So to begin, we must identify the Reynolds number formula. And that formula is represented the following way. So we have Reynolds number, RE, is equal to velocity times the pipe diameter or the channel diameter and the density of the fluid we are referring to over the viscosity of that fluid. So we are interested in finding the velocity of that fluid. So we have to manipulate this following formula. And the version of that formula we obtain is the following. We get velocity is equal to Reynolds number multiplied by the viscosity of that fluid over the pipe diameter multiplied by the density of that fluid. And it looks like a couple of these values were already identified to us and others weren't, but we'll be able to pull these out very simply. To begin, Reynolds number was given to us at 3,500. So we're in that transitional period or area of laminar and turbulent. Next up, we have the viscosity of the fluid, and that is equal for water in this case, 8.9 times 10 to the negative 4. And the unit is Newton second over meter squared. Diameter is going to be 0.025 meter and 0.00015 meter. We're just converting from millimeter and micrometer to meter. And finally, the density of water is 1,000 kg per meter cubed. Now that we have everything identified, we can just plug and chug and find our two velocities. So in doing so, let's go ahead and work this out. So first off, for our first diameter, we get the following. So viscosity is equal to our Reynolds number of 3,500 multiplied by our viscosity, 8.9 times 10 to the negative 4. And that is going to be over 0.025, and that's going to be multiplied by 1,000. Working this out, we get a velocity of 0.125 meter over second, and that's our first velocity. So let's go ahead and repeat this process for the second velocity we have. So keeping in mind, every number will remain the same or value except for our pipe diameter. So our numerator remains the same. Now this is where we have the change. 0.00015 multiplied by 1,000. Doing the math here, working it out, we obtain a velocity of 20.7 meters per second. So this is the solution to problem 17 for homework number 6.